Yeah, good evening all. So before I start, can anyone please confirm? Can anyone please confirm whether my voice is clear or not, right? Yes.
Yes,
Yes, clear.
Thank you. Right. Okay. So in the last demo session, I was just briefing about what is big data, why Hadoop and Spark, drawbacks with the current databases, Hadoop advantages, and Hadoop. I'll be discussing about the Hadoop components and job market. So here, Hadoop is meant for two things, for storage and for processing. It is meant for storing data and for processing data. For storing, we doesn't use any databases because databases have got some drawbacks, right? Despite of those drawbacks, we go with a file system called Hadoop distributed file system, right? And for processing, we go with MapReduce. And with for processing, we go with MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is meant for batch processing. It is not for online processing. There are two types of applications: online applications, batch applications, user interactive applications, right? Online applications means user interactive applications. Here user gives the input. Yes, booking a movie ticket, moving a online transaction, right? Yes, moving a online transaction. Batch applications, right? User non-interactive applications. User non-interactive applications. Here, user is nowhere required. In online applications, user required. In batch application, user is nowhere required, right? So railway ticketing PNR status, right? Here internally, like it happens in automatic fashion, right? So credit card statement generations for millions of customers. Here user input is nowhere required. And most of financial applications, right? Most of the financial applications are batch applications. And the databases like Oracle are not used to store Hadoop data because databases limited storage in GBs or in TVs, no parallel processing in most of these databases. As volume increases, speed decreases, right? As volume increasing, speed decreasing. And if you observe this, total amount, select total amount from sales one, total amount from sales two, total amount from sales three. So record to record, different number of, so from record to record, see here, as volume increasing, speed decreasing. Here 10 records, 1 lakh records, 1 crore records. If you see, the first query executes faster because record to record, query to query, as the volume increasing, speed decreasing. And complexity increases, speed decreases, right? Yes. Query to query, if the sum, average, and standard deviation. Query to query, right? It increases, speed decreases, right? Yes. Okay. Databases can handle only structured data. Databases can handle only structured data. They cannot handle unstructured or semi-structured data, right? That is the major drawback with database. Hadoop advantages means unlimited data storage, very high speed processing like parallel processing, can handle all varieties of data, open source, no licensing required, and commodity hardware. Means it can run on any hardware. Unlimited data storage because of there is a feature horizontally unlimited scalability. Horizontally unlimited scalability. Or okay, I'll come back to this horizontal and unlimited scalability, but before that, before I go with Hadoop advantages, you need to know about Hadoop cluster. Hadoop cluster, right? Group of CPUs. Group of CPUs. Nodes connected in a network. Connected in a network, right? Group of CPUs nodes connected in a network. There are two types of nodes. There are two types of nodes. There are two types of nodes, right? Yes.
So what is the meaning of nodes? Is it like a computer or a system, a standalone system?
Group of CPUs, right? I'm saying nodes connected in a network. Group of CPUs. What do you mean by cluster? Group of CPUs connected in a network. There are two types of nodes, right? Master node, slave node. So here Hadoop follows master slave architecture, right? Hadoop follows master slave architecture, not client server architecture, master slave architecture. Cluster means group of nodes connected network. There are two types of node, master node, slave node. Okay. So here we will be seeing master node or slave node, right? Within this master node, right? It's like in Hadoop terminology, there is a name node. There's a service which is running, right? Name node. Slave node means there is a service which is running like the data node. We call them as data node. Master node, name node in Hadoop terminology, right? And slave node, data node. See, I said Hadoop follows. Yes, every CPU we call it like a node. 10 nodes means 10 CPUs, 10 systems, 10 systems. See, this is master. These are slaves. Single master and multiple slaves. Master slave architecture, right? Master and slave architecture. Master slave, master slave, master slave. Slave 1, slave 2, slave 3, so on, slave n. These are the slaves. Slave nodes. Master node. Slave nodes, data nodes we say. Data nodes we say. So in Hadoop, master slave architecture, collection, this entire thing we call it as a cluster. Cluster. Group of nodes connected in a network. One master and remaining all are slaves. N node cluster, 40 node cluster, 60 node cluster, right? So here single master and multiple slaves. So here why the name data nodes means data stored within the slaves, data processed by the slaves. Data stored and data processed by the slave nodes, right? So here a file f1.txt, f1.txt, right? Yes. f1.txt divided into smaller parts, right? Smaller parts. Each part is stored across the multiple slaves. So here, right, the file divided into smaller parts, they are stored across multiple systems, slaves, and are processed parallelly. So what are the responsibility of master node? What is the responsibility of the slave node? Master node responsibilities: assigning single, yes, in the latest in the versions, right? The latest Hadoop versions, we can have multiple master nodes. Previously, right, only one, but in the latest Hadoop version, right, we can have multiple master nodes. Means multiple name nodes we can have. We'll say multiple name nodes we can have, not but yes. So here single master and multiple slaves. Master node responsibility means, so 10 lakh records in this, 10 lakh, assume 10 lakh records, 10 lakh records, data is distributed. Executing this 10 lakh records, nothing but task one. Executing this 10 lakh is nothing but task two. Executing this is task three. Task who assigning the task? Master. Who assigning task to the slaves? Master will assign. Observe this. Master node responsibilities. Master node responsibilities. Responsibilities, right? Master node responsibilities first. Task assignment. Task assignment. Second is like load balancing. All the slaves should be given the task equally. We need to balance the load. Who does this? Master. Load balancing. Third is like fault tolerance. We have got a lot of discussion on this fault tolerance, but as of now, I will just say in a single word. Master node and name node. Within the master node, there is one service which is running. We call it as name node. It's a service. Okay, fine, right? Fault tolerance. Task assignment means assigning tasks to the slaves. Load balancing. Load balancing, right? Yes. So the task should be equally assigned to all the slave systems, but we cannot burden a particular slave by assigning more tasks. So that is everything taken care by the master. Fault tolerance means, observe here, if multiple tasks T1, T2, T3, T4, right? Observe here, right? Okay, four tasks, right, are assigned. See, T1, T2, T3, T4, right? Four tasks are executed by the four slaves parallelly. Four tasks are executed parallelly by the four slaves. During this execution, suddenly, if any one slave goes down, then the task of it will be assigned to any of the available slave. This process we call it like fault tolerance mechanism. If any slave goes down, as they are machines, right? If any slave goes down, then the task of it will be assigned to any of the other slave. This process we call it like fault tolerance. Health monitoring. Health monitoring, right? Yes. Health monitoring means before assigning task to the slave, first master node will have the entire information about each and every slave, their health status. So this health monitoring, right? So mainly for assigning tasks, balancing the load, fault tolerance in the absence. Suddenly, if any node fails, the task has to be assigned to the other slave, and health monitoring the health of the slaves. This is what master node responsibilities.
So what is load balancing? Can you come again? Load balancing.
Load balance means, for example, here, very simple, right? For example, a construction, building construction. Assume I'll give a labor example, building construction. For example, you are the master, you are the owner. You have got labor. You have brought four labors for working, for constructing, right? Labor one, labor two, labor three, labor four. For example, if building construction, right? If you brought four labors, the work, whatever work is there, you divide into multiple. Means you will distribute that into multiple slaves. If you want to distribute that, just like a file divide into smaller parts, then only you can distribute, right, across multiple systems. Here also, whatever job, the constructional job, right, divide into multiple. And think you got 8 tasks. 8 tasks means how will you assign? 2 tasks to this, 2 tasks, 2 tasks, and 2 tasks. I'm assigning 2 tasks to each. This who is assigning? Master node. Master is assigning. You cannot assign 1, 1, 1 and 5 tasks to this. Equally balanced, right? You cannot assign 5 tasks to this single slave and remaining all 1. Equally balanced. Right? What are the tasks?
So if the fault occurs, then how it will load balance?
See here, for already the slave 1 is executing 2 tasks. Already this is executing 2 tasks. This is executing only 1 task. If this is executing only 1 task. If a new task comes, to which slaves I need to allocate? To which slaves? Because already 2 tasks are in the waiting state for this. 2 tasks are in the waiting state for this. Means once they complete these 2 tasks, again 2 tasks are ready for it. 2 tasks, if they're complete, again 2 tasks are in the waiting states. But for this, only 1 task is in the waiting state. For this, only 1 task. If a new task comes, to which I need to assign? S3 or S4. Who takes care about these things? Master. Who takes care about all this? Master.
Does it happen automatically, internally?
Yes. This everything happens internally, right? Yes. So master node responsibility, assigning tasks, load balancing, fault tolerance, health monitor. So more, I'll be discussing about the Hadoop architecture, right? Storage architectural and processing architecture. Everything I'll be discussing in brief. So just I'm giving overview as of now. So that is master node responsibilities. About all these things I'll be discussing in brief in the architecture, right? Storage and processing architecture. But slave node responsibility is what? Slave node responsibility. Storing the data. First one. Processing the data. So just now someone was okay, just now, right? When everything done by the slave node, storing of the data done by slave, processing of the data, then what master node does means all this. Master node, it won't work, it will just assigns, right? Okay, task assign, load balancing, fault tolerance, health mark. Slave node responsibilities, 2 responsibilities: storing the data and processing the data. How data is stored, how data is processed, I'll be discussing in brief, right? How exactly the data is getting stored, how exactly is data is getting processed. I'll just discuss multiple case 1, case 2, case 3, and case 4, right? So depending upon this data. So Hadoop advantages: unlimited data storage, very high speed processing, can handle all varieties of data. Open source, no licensing required. Commodity hardware, right? So before I was just saying, okay, I'll come back to this.
So when you say there's no license required, does it mean it is free? One can use it freely.
What is that? Open source you're talking?
Yes. Is it free of the software is free of charge?
Yes, it's free of charge. No need, no licensing, right? So all these, most of these Hadoop and Spark products are from Apache. So we go to Apache mirrors and we'll download from there and we'll install right from there. We're going to configure Apache mirror site is there. I'll show you from where you can take it. Most all these products are from Apache, right? So Apache mirror site will be there. From there we can download, right, the stable versions, and we can configure these things. No licensing required.
Okay.
And here unlimited data storage because of horizontally unlimited scalability. unlimited data storage because of a feature. Because of a feature, right? Horizontally unlimited scalability. Horizontally unlimited scalability. Because of a feature, horizontal what do you mean by horizontally unlimited scalability means? For example, if you are running a small business, right, with a number of slaves, 1, 2, 3, 4. Your business has increased, branches have increased, customers have increased, data also increased. You cannot go with the same number of slaves, same number of systems. You need to increase it horizontally. They keep on increasing. If your business is increasing, your customers increased, data also increased. If customers increased, okay, if data increased, customers increased by 100 times, data increased by 1,000 times. You cannot go with the same number of slaves. You will keep on increasing the slaves. Horizontally unlimited number of slaves can be added. Horizontally unlimited number of slaves can be added, right? Can keep on adding. If data is increasing, your systems are slaves. Commissioning and decommissioning, we say adding and removing of the slaves. That is horizontally unlimited scalability.
Who's responsible for adding it?
So we have got
who is responsible for adding it?
Adding and removing that, we'll have that Hadoop admin will be there, right? He'll be taking care about this adding and removing. As per this data requirement, out of depending upon the data volume, what are the number of slaves, what are the required, we need to add or we need to remove, depends upon that data, the incoming data value.
So when you remove and add, won't data be lost? The slave you removed before, where are you going to keep the data?
Okay, observe, right. So based on the requirement data volume and that based on the incoming data, right, we'll just estimate what are the number of slaves requirement. So we want like 40 node cluster depending upon that incoming data and data value. So configuring like 40 node cluster, what is the n node cluster? Right? Horizontally, you can, if your data is increasing, you can keep on increasing the slaves, I'm saying. Today, if you're running with n number of slaves, tomorrow you can keep on increasing, right? Very high speed processing because of parallel processing. I'll give a labor example of this parallel processing. For example, one person preparing one item, taking 1 minute. One person preparing one item, taking 1 minute. One person preparing one item, taking 1 minute. One person preparing 10 items, taking 10 minutes. One person preparing 1 minute. One person preparing 10 items, taking 10 minutes. One person preparing 100 items takes 100 minutes. Same one person preparing 1,000 items takes 1,000 minutes. But parallel processing means Parallel processing. To prepare one item, 1 minute. To prepare 10 items, 1 minute. To prepare 100 items, 1 minute. To prepare 1000 items, 1 minute. One person, 1 minute. 10 persons, 10 items, 10 minutes, 1 minute. So here for one item also 1 minute, 10 items also 1 minute, 100 items also. Means here 10 persons working parallelly, preparing, right? Here 100 persons running parallelly, right? 1 minute only. Here 1000 persons. So their persons, here we are saying systems. Parallelly, the systems are running parallelly, slaves are running parallelly and executing the same job. So very high speed processing because of parallel processing. Can handle all varieties, structured, unstructured, and semi-structured, right? Open source, no licensing required. And commodity hardware. Now here I got some query, right? Why databases? One more query. Why databases like Oracle won't support unlimited storage? Why databases like Oracle won't support unlimited storage? Why database like Oracle won't support unlimited storage? Databases. Limit on
Performance
number
will
of,
go down.
yes, what is it?
Performance will go down.
Yes. Databases and max limit on number of slaves. Max limit on number of slaves. So first, even in real time, databases like Oracle can go with multiple slaves, right? So Oracle max limit means what is the two? It can go with maximum 256 nodes or CPUs, right? MySQL can go maximum with 54 nodes. But
If we add more databases then in horizontally, then also it can be also unlimited storage, right?
See, data is why we are going with multiple slaves means data is going to get distributed. So in databases, one table, database table, do you think will it be stored across multiple systems? Will it be divided into multiple parts? Will it be stored across multiple systems? A database
No.
table, do you think it will be stored on a single system or distributed across multiple systems?
Single system.
So here, okay, single system, right? So here, okay, if you keep on storing the data, right? Oracle can go with a maximum 256 nodes. Once they get filled, right, they cannot support data further. Okay, MySQL Express can go with 256. I will come back to it. So DB2 can go with maximum 256 nodes or CPUs, and SQL Server, right? SQL Server also, they are supporting maximum 256, right? So like For example, once it reaches, even like it reaches 256, right? But just like your mobile phones. See, for example, like for mobile phone consisting of 64 GB internal storage, 64 GB internal storage. If you store entire 64 GB, what happens? Your performance of your phone degrades, right?
Yeah, hang.
It hangs or it will be opening that applications very slowly, right? If entire 64 GB is filled. The same way, if Oracle, if 256 nodes, if entire thing is filled, right? The performance of this Oracle will be degraded. Sometimes it won't even start. So same way like MySQL or DB2 SQL Server Max, they can support 256. Beyond that, they cannot support, right? But you have got some specialized databases. If you have like a Teradata can go up to 512, right? They can go up to 512 no CPUs, right? And Netija, we have got like Netija. It can also go with 512, right? For storing the data, it can go with 512 nodes or CPUs. Vertica also. One more specialized database used for data warehouse purpose, right? They can go with one. But Teradata and Netija currently they are supporting 1024, right? 1024 nodes. Both Teradata and Netija supporting 1024 nodes, right? Yes. But still, we cannot say like unlimited data storage, right? We cannot say unlimited data storage. Once data gets filled, they cannot support data, right? Once they get filled, it cannot support data further. Okay. But there is no limit. But there is no limit. Number of nodes. But there is no limit on the number of nodes that Hadoop can have. But there is no limit on the number of nodes that Hadoop can have, right? Yes. Horizontally unlimited scalability. Horizontally, you can keep on adding the slaves. Horizontally unlimited scalability. This is the feature, right? Where we can go with unlimited data storage. Yahoo, when first time implemented, when first time implemented Hadoop, went with 4,000 slaves, Currently, Yahoo going with it's Yahoo going with 12,000, right? 12,000 slaves for storing its data. And
So I have
Facebook,
a query.
1 second. Facebook, when first time implemented Hadoop, went with 8,000 slaves. Currently, Facebook, right? Yes. $42,000 slaves. Nodes, right? For storing its data. Right. So you have some query, right? What was it?
Yes, sir. Sir, you said that the Hadoop stores information in form of a file system. So
Yes.
does it mean that it cannot store information just like the way Oracle store information in form of table and row?
So yes, no. So in Hadoop, data is stored in the form of files. Not we won't use any database, right? In Hadoop, we go with files, right? So HDFS, Hadoop distributed file system. Hadoop distributed file system. So here Hadoop is meant for storing and processing. So we'll be discussing in brief, right, how exactly the storage is going to happen, how this processing is going to happen within the Hadoop. In brief, I'll be discussing step by step. But we are not using database. We are using Hadoop distributed file system. We'll be discussing about this HDFS, right? Hadoop distributed file system. And we have got some commands, just like Linux commands. We have got some commands, HDFS commands, using which we can work with. So before I go with HDFS, I'll also just brush up with this Linux commands, right? Okay. Okay, fine. For processing, we are going with MapReduce or Spark. Okay, coming back. So why database like Oracle won't support means, yes, they have got some limit on the number of threads, but there's no limit on number of nodes that Hadoop can. It can go with any number, like not only like 256 or 512,024. It can go with 4,000, 12,000, or 42,000, right? Unlimited data storage is possible. So Hadoop is proven in the market storage point of view, that is unlimited data storage, and also processing point of view, as I was discussing, right? So it has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. So this taken, what is that? Oracle has taken 3.5 days, MySQL 6 days, Teradata like 4.5 hours, Netija has taken 3 hours, Hadoop has taken 4.3. That is latest version of Hadoop has taken 2.4 minutes, right? So I also just brief you about Spark. What is Apache Spark? Why is PySpark made for PySpark? So I was saying that data is generating enormously, right? So large amount of data is generating both through offline and online, right? So we require some proper tools, right? Yes. This data, generally the data consists of hidden patterns, market trends, and customer preferences, right? So we require some efficient tool, right, for performing different types of data operations on this huge data. So we go for technologies like PySpark to crack the big data and gain benefit from it. So combination of Python and Spark is the very efficient way for the build of this big data. So Apache Spark community came up with a tool called PySpark. That is Python API for using Apache Spark. Very high speed processing, huge data it can process in quick time. Today that industry is expecting that such kind of technologies where that data can be processed, that too not small data, huge data, right? Yes. Just I was talking about some real life use cases of PySpark, right? Used in commercial sectors like Spark real-time processing, right? We say Spark real-time processing in bank and financial systems for retrieving the customer's information, social media profiles, and also in healthcare in just analyzing the patient records and identifying which patient is able to, and identifying that which patient is going to face that issues even after being discharged. Entertainment industry, right? Like there are some OTT platforms like Netflix, which uses Apache Spark real-time processing, right? It processes nearly 450 billion events per day, right? And trade and e-commerce like Flipkart, Amazon, also they use like Apache Spark for advertising, right? Even tourism industry. So coming to this, right, and this Hadoop, I'll be discussing like Hadoop components, Hadoop ecosystem components, right? Yes. So we have got some storage and processing systems I'll be discussing, right? First thing like the HDFS, that is for storage. HDFS for storage. Okay. So this is a distributed file system, right? We'll be discussing commands on this. And map reduce, it's an execution model. So for parallel processing, it is also, it's meant for processing, but it was mostly used right previously. But when Spark has come, Spark is mostly preferred. And one more important component that we discuss is Apache Hive, mostly used. Even in the interviews, they ask mostly that interview questions will be more on this kind of Hive. It's a kind of data warehouse kind of environment. It's a kind of data warehouse kind of environment within the Hadoop framework. We use a language called HQL, Hive Query Language, which is almost similar to SQL, right? Almost similar to SQL, right? Right, we will be creating many tables. We will make the data structured here and create tables like internal, external tables, partition, non-partition tables, and to decrease the query, to increase the query performance, right? We have got like bucketing, indexing, partitioning, right? Yes. And apart from this, one more component which is mostly used, Scoop, the full form of it, SQL plus Hadoop. SQL plus Hadoop, right? The first two characters of this and last three characters, right? For import or export operations. So generally, how you will bring data to Hadoop environment? We'll import the data, right? From different data sources, from different databases, we'll pull the data from. How to pull the data, everything will be discussed. Import or export operations. And also, once the data is processed and stored in HDFS, again from HDFS, you can carry it, right? And also I'll give knowledge on one NoSQL database. What is the advantage of NoSQL? A random access. A random access, right? Hadoop, this follows sequential access, but if we combine with NoSQL, you can get random access, dynamic access. Both combined of sequential access plus random access combinedly we can perform, that we call like dynamic access. And schemaless behavior, right? In SQL, schema mandatory, here no schema required. Record to record, different number of fields can be maintained. Dynamic, okay. Random access, you can go schemaless behavior, right? So we'll be discussing a NoSQL database like HBase, right? Which is Hadoop database, we say. HBase is one NoSQL database we'll be discussing up. And there is one more component like Yarn, yet another resource negotiator. So the previous in Hadoop versions, there were some drawbacks. Everything got rectified from Hadoop 2 version onwards. So there are some architectural changes from Hadoop 2. So everything I'll be briefing you within this Yarn and Yarn architecture, Yarn components. Yes. And there's one more like Zookeeper. Like the name itself saying, right? It acts as a mediator between that. So for establishing connections, okay, for all this Zookeeper is preferred.
Your voice is not
and apart from this, before PySpark, I'll give knowledge on streaming, right? Is my voice clear to all? Can anyone please confirm? Hello?
No, your voice is breaking, sir.
Voice is breaking.
Yes, sir.
1 second.
The explanation of Zookeeper, we didn't get it. And Hibernate, we didn't get the explanation.
Now is my voice clear to all? Hello.
Yes, sir.
Yes.
So HDFS is meant for storage. MapReduce is a parallel execution model meant for processing. So Hive, it's a data warehouse kind of environment in Hadoop framework. So we use a language called HQL, which is almost similar to SQL. Hive query language, we say similar to structured query language, SQL, right? So here we'll make the data structured and we'll create tables, right? Like internal, external tables. We have got partition, non-partition tables. And for improving the query performance, right, we have got concepts like partitioning, bucketing, indexing, right, for better query performance, right? So Hive is mostly used in most of the projects. So we have got separate jobs available only in Hive, if you've got knowledge on Hive. So I'll be spending more time on this Hive component and also like scoop component, right? For import and export operation, how to pull the data from different data sources to Hadoop environment. So you are going to import the data and see SQL plus Hadoop scoop full form, the first 2 characters of this and last 3 characters of this. Fine, right? So for import or export operations, NoSQL, right, for random access. Generally, Hadoop performs sequential access, but Hadoop and NoSQL, right, combinedly they can perform sequential and random access, dynamic access, we say. And one more thing, advantage of NoSQL is schemaless behavior. No need of any schema like in SQL, like SQL, right? We require record different number of fields can be maintained. As part of this course, we'll be discussing one NoSQL database, HBase, Yarn, Zookeeper, right? Yarn and Zoo. Yarn is in from Hadoop 2 onwards, we have got some architectural changes. I said previous drawbacks, whatever we have got, everything got rectified. Everything we'll be discussing in the Yarn, right? The Yarn architecture. It's a cluster manager and Yarn components. The total, I'll just discuss about the total Yarn architecture. Zookeeper is, it controls and coordinates all the components, right? All the Hadoop components, it controls and coordinates. And for any connections, anything, right? Zookeeper will take care, right? And I'll also give knowledge on this streaming data, live streaming data. We use like Flume, Kafka, right? I'll give knowledge on this Flume and Kafka. It's not specified here in this course content, but it's used for streaming data, right? What do you mean by streaming data? The data which keeps on incrementing, the data which keeps on generating, the data which keeps on incrementing, data which keeps on generating. Like, if you take any static file, for example, MP4 file, MP3 file. If you take any movie, if you have downloaded a file which is already downloaded, morning with respect to time, right? Morning if you see, afternoon if you see, evening if you see, after 10 days if you see, the size won't increase, right? The size means any file, txt file or mp3 file or mp4, any file, it is static. But if you take the data, streaming data, morning if you see, after afternoon if you see, morning 2 GB, afternoon it will become 4 GB, after 10 days it will be like 10 GB. Means it keeps on incrementing, just like example like webcam, CC cam, right? The data keeps on generating, right? Which keeps on incrementing, so how to handle that? We have got like Flume or Kafka, and that data also you can pull it into Hadoop HDFS and we can process it, right? And PySpark, right? PySpark. So here like Spark Core, Spark SQL, Spark Streaming. And we're discussing mainly about this, right? Spark Core program, Spark SQL program, Spark Streaming. And a part of, I'll be discussing a part of Spark ML libs, machine learning. Yes. So you can observe this. So you can once again we can go to the course. Just I was giving the basics of this, right? In the next week we are going with the technical part, right? We'll be just entering into that how exactly the data storage and data processing is going to happen, right? So you can see the two courses combined together. We are providing that Hadoop and Spark, that is with Python implementation. So the Spark is with Python implementation, right? So this is the course content. Hadoop, HDF.
So are you not covering OG for job scheduling?
Yes. Say, okay. Uzi, no. If you want, at the last, I'll provide knowledge on it. So map reduce, scoop, right, for SQL and Hadoop, Eon, NoSQL, HBase, Hive in brief, lot of discussion on this Hive, like Hive, difference between HQL and SQL, Hive Metastore, loading data to Hive tables from HDFS, from local files, different types of tables, inner table, external table, working with unstructured data, working with XML data, working with JSON data, URL weblog data, right? And multi-table file inserts, local files, HDFS files, UDF, user-defined functions, user-defined aggregated functions, user-defined tabular functions, partition, non-partition tables, dynamic partitions, multi-column partitioning, static partitioning, performance tuning mechanism, bucketing in Hive, indexing in Hive, Hive examples, Hive and HBase integration with NoSQL integration, right? And coming to PySpark in brief, PySpark introduction, comparing with other technologies, the Spark, PySpark, the speed of Spark compared with other technologies, right? Yes. Real life usage, web, okay, what do you mean by Spark session, Spark context, repartitioning, broadcast variables, Spark RTD computation, steps in RTD computations, persistence options, core computation, PySpark core computations, groupings, aggregations. In Spark, we have got many inbuilt actions and transformations. We need to write huge codes. We'll discuss one by one actions and one by one transformations in brief. Yes. PySpark SQL data frames, right? Making data structured, like making data structured like that. 1 second.
Sir, can you show us how to download it? How to software?
Data. Yes, I'll discuss that. So before I go with the practical, first I'll show you like how to work with basic Linux commands, next coming with HDFS commands and the other things, right? So this PySpark converting data frames, working with data frames, row class, column class, select, collect, where, filter, drop, order by, group by, join, union, flat map, sample, fill, nulls, and PySpark SQL functions, window functions, aggregate functions, date and timestamp functions, JSON functions, right? Inbuilt functions of PySpark one by one I'll be discussing in brief with working examples. PySpark external sources, working with SQL, Hive integration, Spark and MySQL, working with CSV, JSON, wide and narrow transformations, adding, hiding nulls, handling nulls, window function, writing data back to external sources, deployment modes, local mode, cluster mode, applications like what do you mean by stages, tasks, drivers, executors, Spark application, how to submit a Spark job, right? Performance tuning and streaming concepts, integration with Kafka and PySpark MLlib, right? So this is the thing, right? In brief, we'll be discussing, right? I said like it's a weekend batch every week. So next Saturday, right? Yes. Same, we'll start at 6:30 p.m. So the link will be changing, right? So everyone get enrolled if you are interested in going with this big data engineering, right? Hadoop and it's like Hadoop and PySpark, both will be covered in brief step by step. So every session is video recorded. You will be getting the recorded video. Clear notes will be provided. Yes. Software also I'll be providing, right? Fine. You can see in the chart panel, right? So yesterday's video also is provided, right? You can see the course content. So demo link is given, means yesterday's video link is given. You can copy that yesterday's video link. Course content is provided. Demo videos. Okay.
Sir, which language we usually interact with Hadoop in this class?
Okay, 1 second. So HDFS, okay, we have got some commands. In map, okay, in scoop, okay, how to bring data and from databases to Hadoop and Hadoop to databases. Yarn, no, HBase, okay, it's a database, right? HBase is a NoSQL database. In Hive, we use HQL language, but Python language, right? Spark with Python, we go with Python implementation. And in Hive, we use HQL language, high query language. In PySpark, Spark with Python implementation. And all these are databases, NoSQL databases. Scoop is for bringing data into Hadoop and import and export operations. So mostly, right, we'll go with Python language. Okay. So the prerequisites for it, right? Basic Linux, basic SQL, right? Basic Python is required, right? So Linux, anyhow, I will be discussing, I'll be briefing you about the commands before I go with the practical part. Even before I go with the practicals, I'll also brief you with the syntaxes, right? For 2 hours, for 2 hours, I'll be just briefing you about all the Python syntaxes. And for 2 hours, I'll be briefing you about all these basic Linux commands before I go, right? So
So you do any installations or we'll get access to the your server and we'll
yes.
log it?
Yes, no. I'll be providing you the VMware workstation, right? In that everything will be installed, right? All the Hadoop components and Spark, right? Like all this Hive, MapReduce, HDFS, NoSQL, HBase, Flume, Kafka, Spark, everything I'll just configure and I'll provide you that workstation, right? You can work on it. And later in PySpark, working with PySpark, I'll show you on different environments, right? You're working with Jupyter Notebook, working with Spider, right? And I'll be showing you those things.
Meaning, do we have to physically install in our laptops, or like we get access to your server and then?
No. I'll just forward you like nearly like 6 GB. I'll forward to your Google Drive, right? That you need to download and you need to install that in your systems, right? And you can work with it.
Oh, okay.
I'll just provide, like it will be nearly like 6 GB, right? That I'll be providing you, where everything, all the components you can work with. That you need to download it and how to install, I will demonstrate everything, how to work, right? Once it's a RAR file, once you download, it will go nearly like 8 to 9 GB, right? Yes. Right. Nearly 9 GB you need to extract, you need to download and you need to extract and work with it. So it looks very simple if you're attending the sessions regularly and if you're doing the practice, you are not going to write big or huge tasks once you understand, like. So already know Python is a simple language, like in normal English statements. It won't be like Java, it is not that complex. Yes, but before PySpark, right? So for the first, I'll be discussing by the time I start with PySpark, right? It will take nearly 1 to 1.5 months, right? So by the time if you people have got any source of learning Python, you can update with Python. Before I start with PySpark, first I'll go with Hadoop components, right? So by the time, so even I'm running some Python batches, right? Morning 6 a.m. there is a new Python batch started recently, right? 1-2 days ago. Still, if anybody, right, you can just check this DURGASOFT for this. I am also taking Python batches. Okay, fine. So just get enrolled and the link is going to change. You can see that link in your email. Check your emails, right? If you already got enrolled, you'll be getting to your mail IDs. So don't forget to send the screenshot of your payment to this DURGASOFT online training. They have mentioned clearly there the mail ID, DURGASOFT. They're given in the bold form, right? Sending the screenshot of the payment. Then only you will be getting the link, the Zoom link, right? Meeting link. DURGASOFT online training @gmail.com. The screenshot of your payment, right? So if any concerns you have got, they have provided their mobile details, right? Contact details. You can go through it. So it's a 12,000 is the fee structure for both Hadoop and PySpark entire, right? So you.
Hello, sir. I have a question.
Yes.
Somebody who has a knowledge of data science should the person also enroll for big data? What is different between big data and data science and data engine?
So yes, 1 second. See, this is data engineering, right? You see more like data engineering. So where data management you see, right? Data storage and data processing you are going to perform here. In data science, you perform data analysis, data predictions, right? You perform data classifications, data recommendations you see there in data science. So based on the current data, you are just going to perform some analysis, or you are going to perform some predictions, or you are going to perform some classifications, or you are going to perform some clusterings or recommendations. In data science, we have got many algorithms, clustering algorithms, classification algorithms, predictive algorithms, right? So there you'll be learning about all those algorithms and techniques, right? For data analysis, predictions, clusterings, and recommendations. Here you will be learning, right? How to bring the data, how to handle the data, like how to handle different types of data, structured, unstructured, semi-structured, right? How to store it and how to process it, right? As per the business logic, how we are going to process it. And also the speed of the processing, we are using Spark, PySpark. It's for processing, right? So for processing, what are the different APIs available, like Spark core APIs and data frame APIs are there, right? Where we will be discussing more on those in the case of Spark. This is for data management, you go for this. And for data analysis, predictions, or classifications, you go for the data science. Means a typical data scientist will depend on this data engineer, right? A typical big data guy. A data scientist depends upon this big data guy, right? Means first you need to bring the data, pull the data, you need to process the data. Then comes analyzing of the data, right? See, now as of now, okay, but later a data scientist need to have the knowledge about this entire big data concepts, right? For storing and processing, right? Yes. Fine. So yes, any more queries, right? Yes.
Hello, sir.
Yes.
Please, Django and Tony. The head
Yes,
said
those things you can discuss, right? You can ping me that groups.
I've pinged you already since you didn't reply me.
Fine. You're asking about, so I was busy with the weekend classes. I'll forward it. You're asking about the notes, right?
Yes, sir.
Okay, fine. Okay, so if I'm done with your queries, right, I'll sign off for now. Meet you next Saturday at 6:30. So just get enrolled for, so then the payment details, everything you can see. Also, they'll be posted to your mail IDs. Yes, thank you all for your time. Thank you all. Meet you next week. Bye. Yes.